Hi, everybody. Welcome to section 2.10, and we're going to be talking about the elasticity of demand. For the elasticity of demand, we know it's a measure of how demand reacts to price changes. If I increase my price, what happens to my quantity sold? My revenue is going to equal P times Q. If I raise the price and my quantity doesn't change, my revenue is going to go up. Is my revenue increasing, decreasing, or staying constant? We have this formula where we have the absolute value, which just makes everything positive. The demand function is always decreasing because as the price increases, the quantity demanded goes down. But that doesn't mean the revenue does. The elasticity tells us what happens to our revenue. And this just says price over quantity times the derivative of the quantity with respect to the price. And because I know Q equals D of P, I can just change that. And this right here is one notation for the derivative, and this is another notation for the derivative. The demand functions are decreasing when the price increases. When the price increases, the quantity decreases. What happens to the revenue? When the price increases, will revenue go down because the demand dropped so much? Or will revenue increase because demand didn't drop very much at all? So now I increase the price, I'm bringing in more money for the same amount of items sold. The particular prices and quantities don't matter, and everything is treated as a percent change. The quantity E will fall into one of these three scenarios. It will either be less than 1, equal to 1, or greater than 1. When the elasticity is less than 1, we call that an inelastic demand. An increase in price will increase the revenue. So the price should be increased. If E is greater than 1, we call that elastic. And an increase in price will decrease the revenue. When E is greater than 1, I should decrease my price. E is equal to 1. That's called unitary. That's the perfect price. I should not change that price. It's the critical number of the revenue function. Numerical interpretation of E. If the price increases by 1%, the demand will decrease by E%. If I increase by 1% and I decrease by 0.5%, that was a good increase because my price increase is going to give me more revenue than I had before. But if I increase my price by 1% and my demand drops by 2%, now my revenue is going down. So my E is going to be greater than 1. The perfect price is when E is equal to 1. Here's our first example. The demand function for a product is P equals 300 minus 0.02 Q. And I want to find the elasticity of the demand for a price of $70. Will an increase in price lead to an increase in revenue? E is equal to the absolute value of P over Q times dq dp. I want to find the elasticity. I know P equals 70. And I can find out what Q equals. If P equals 70, then I have 70 equals 300 minus 0.02 times Q. So I have 0.02Q is equal to 300 minus 70. Divide both sides by 0.02, or I can multiply both sides by 50. So Q is going to equal 50 times 300 minus 70, which is 230. That means Q equals 11,500 when P equals 70. Now I have my P and Q. The other thing I need is I need the derivative of Q with respect to P. First thing I'm going to do is I'm going to start with P equals 300 minus 0.02Q. I want to solve for Q. I'm going to add 0.02Q to both sides, which gives me 0.02Q, and subtract P from both sides, which equals 300. These cancel, minus P. And then I'm going to divide both sides by 0.02Q, which is the same as multiplying both sides by 50. Now I need to take the derivative of that. And now I need dq dp, which is equal to the derivative of this. And this is the same as 50 times the derivative of 300 minus p, which would be minus 1, which equals negative 50. It's good because it always should be negative. So Q is equal to 11,500. dq dp is equal to Q prime is equal to negative 50. I have everything I need for my formula. So my elasticity is equal to the absolute value of P over Q times 50. Nothing's negative. I can take away my absolute value. This is going to equal 3,500 divided by 11,500. I don't actually need to know what that number is to answer this question. I know this is less than 1. E is less than 1. Let's see what that means. When E is less than 1, the demand is inelastic and it should be increased. Find the elasticity of the demand for a price of $70 equal to 35 over 115. You can use your calculator. Let's see, this is 7 over 23, which is obviously less than 1. Will an increase in price lead to an increase in revenue? This is inelastic. It said that the price is inelastic. It should be increased. Inelastic should be increased. Unitary remains unchanged. And sorry, the elastic doesn't go with decreased, but if you got the other two by a process of elimination, you could get that. Will an increase in price lead to an increase in revenue? Yes. We need to increase our price. Now they're asking me where the elasticity of demand is unitary. And where it's unitary is where E equals 1. And E equals the absolute value of P over Q times the derivative of Q with respect to P. Well, I don't know P or Q, but I can solve for Q. That way I'll just have one variable. So here I can solve for Q. I have P equals 300 minus 0.02Q. I'm going to add the 0.02Q. So I have plus P equals 300. I subtract P from both sides. 2 100ths is the same as 2 over 100. And this is really the same as 1 over 50, or Q over 50 is equal to 300 minus P. Multiply both sides by 50. Cancel. I get Q equals 50 times 300 minus P. So Q is equal to 15,000 minus 50P. I have P. I'm just going to leave it as a P. I have Q. The last thing I need is the derivative of Q with respect to P. The derivative of Q with respect to P is equal to 15,000 goes away, and minus 50P becomes minus 50. My next step would be 1 equals, well, P over Q are both positive, so I can say P over Q, and I'm going to leave Q in terms of P. And then I'm going to multiply that by the derivative of Q with respect to P, which we found here is negative 50. We know that this is in absolute values. Really, the only thing it's affecting is this negative 50. So I have 1 equals, I have the absolute value of P divided by, I divide this by 50 becomes 1. I divide the denominator by 50, I get 300 minus P. This whole thing is negative, and I take the absolute value. Now, since I took the absolute value, I don't have to worry about that negative sign. I'm going to get rid of that negative sign. So I have P over 300 minus P is equal to 1. I multiply both sides by 300 minus P. Well, that times 1 equals 300 minus P, and it will cancel this denominator. So this equals P. Add P to both sides, 2P, and I get P equals 150. The perfect price where the elasticity is 1 and is unitary is $150. One more example. The demand function for a product is D of P equals the square root of 300 minus 2P. And we want to find the elasticity of the demand for a price of $89. Let's just start with what we know. We know that the elasticity of demand is equal to the absolute value of P over Q times the derivative of Q with respect to P. We know D of P is the demand function, and this is equal to the quantity. We are going to find P. I can solve for Q in terms of P, which I already have, and then I can take the derivative. Q is equal to the square root of 300 minus 2P. I just take the derivative of this. I'm going to rewrite this as 300 minus 2P to the 1/2 power. I'm going to use my chain rule. when I take the derivative of this. So the derivative of the quantity with respect to P is equal to 1/2 times what's inside to the minus 1/2 times the derivative of the inside, which would be -2. Now, we're going to plug this in to the elasticity. We have P, we don't know, we're trying to find that. We have Q in terms of P. We have the derivative of Q with respect to P. Let's simplify it over here. This will cancel with this, and I'll get -1 over the square root of 300 minus 2p. And don't forget, this is all inside an absolute value. I can get rid of the absolute value if I just make it positive. So I have p divided by, well, the square root of 300 minus 2p times the square root of 300 minus 2p is 300 minus 2p. And that's equal to E. Now I can find my elasticity very easily. E is equal to P they gave me here. The price they gave me is $89. E is equal to 89 divided by 300 minus 2 times 89, which is equal to 89 divided by 300 minus 178, which is equal to 89 divided by 122, which is less than 1. Since it's less than 1, it's inelastic. And remember, inelastic means since I have this I, we're matching the I's. I don't know if you remember me saying that. This is increase. I want to increase my price because I can definitely get more money for the item, and it will lead to an increase in revenue. So will an increase in price lead to an increase in revenue? The answer is yes. Thank you very much for watching. I'll see you in lecture 3-1. Bye-bye.